The next question of lead code biweekly contest 121 is minimum number of operations to make arrays or equal to k.
So in this question, we will be given one array. This array be 2, 3, 5, 7, some random array, and will also be given one k value. Now, in one operation, I can take any number 2, 3, 5, 7. In one operation, I can take any number, and I can change one bit in it. Like if the bit is 1, I can make it to 0. If bit is 0, I can make it to 1. For example, if I pick 5, then binary form of 5 is 105. Now I can pick this number, this bit, and I can make it 1. So 1, 1, 1. The new number that will be formed is 7. So I can replace 5 with 7. So in this way, in one operation, we can pick any number and change one bit in that number. So now so after some operations, we need to make array in such a way that, so let's assume after some operations, our elements became A1, A2, A3, A4. So after some operations, our array become A1, A2, A3, A4. Now this array should be in such a way that when I do XOR of A1, A2, A3, A4, we should get k value. So now the thing we need to find out is what is the minimum number of operations are required to make this condition satisfied. Bro, you can pick the leading zero and ఒకటే zero leading zero అంటే 32 bits కాదు. That you can flip the leading zero bitwise in the borrowing order. For example, then for the number this one you can flip the fourth bit. అంటే immediately next zero లేకపోతే 31th bit చేంజ్ చేయొచ్చు.
ఏదైనా చేయొచ్చు. బేసికల్గా ఇన్ఫినైట్ బిట్స్ ఉన్నప్పుడు ఏ బిట్ అయినా ఇన్ఫినైట్ బిట్స్ వచ్చింది.
And one more condition to flip the bit is, for example, if there is a number, let's say we have 7, we can either select from these three one bit and flip it, or else we can choose any of the leading zeros here. I can choose this number, I can flip it. So the number will become 1, 0, 0, 0, 1, 1. So it need not necessary that we flip from these bits only. We can even flip from the leading zeros as well. So let's see the constraint for this problem. So the array that they give us, the length of this array. So the length of the array, it can be from 1 to 10 to the power of 5. And each element in this array, like 7, 5, all these elements, those ranges can be from 0 to, like array of I, those can be still 10 to the power of 6. And the k value that they give, this k value, it can range from 0 to 10 to the power of 6.
So in this question, basically, let's consider a array 2, 1, 3, 4, and let us take a k value. So k is 1 here, and the array value is 2, 1, 3, 4. So now ultimately our aim is to make this array's XOR equal to k, right? So firstly, let's find out the XOR of the array, and we can observe one thing. Firstly, let's see what will be the XOR. XOR is 4, right? for this array, XOR is 4. We can write 4 as 0, 1, 0, 0, right, in binary. So now my claim is to flip any one particular bit in the XOR. It's enough to flip any one element's bit, any one element which has this bit set, right? So if we just pick any one element and then flip this particular bit, in case if we want to flip this bit in the final job, then basically flipping this bit in any one element will flip it in the final job. Right? So main observation here is flipping one bit, flipping a bit any one number will flip it in the final job. Flip that in the final job. Right? So this observation is sufficient enough to solve the problem. So now what we can do is we can just find the XOR. So in this example, XOR is 1, 0, 0, and our k value is 1. So let us represent it in three 2 powers. So as k is 1, we can write it as 0, 0, 1. So number of flips we need to perform are number of different bits that are present. So these two are different and these two are different. So in total, we need to perform 2 flips. So now here, if we see as k value can't be more than 10 power 6, it will be less than or equal to 10 power 6. And arrays or if we look over arrays or my claim is even arrays or will be less than or equal to 2 into 10 power 6, not more than this. So from this, we can observe that if we just check till 21 bits, it should be sufficient as 2 power 20 is almost equal to 10 power 6. So if we just check till 21 2 powers, then it should be sufficient. So for 21 2 powers, we can initially calculate what is the XOR of the initial array. And then we can just check how many set bits are different in the XOR of the initial array and k. So those many operations we need to perform. That is because we just saw that by flipping any one bit in the array, the final XOR, that bit will be flipped in the final XOR. Right? So if you look over the time complexity, we can say it is big of n plus 32 as we iterate 32, not 32, plus 21 as we iterate a 21 size loop and check how many bits are different. So we can ignore that 21 as that is very small quantity compared to it. And space complexity, we can say it is big of 1. So within big of n time complexity and big of 1 space, we can solve this.